Okay, in this question, a playing card is drawn at random from a deck of cards. For each of parts A and B, say whether or not the events are mutually exclusive or overlapping. Then calculate the probability that either event A or event B occurs. Okay. So, part A. Event A is drawing a red card, and event B is drawing a club. Okay. Event A is red card, and event B is the probability of a club. Well, since clubs are black and red cards are obviously red, there is no overlap. Okay, there's no overlap. There's no card that is both red and black. So these are mutually exclusive events. Okay? No card is both red and black. So these are mutually exclusive events. Okay, so now we move on to finding the probability that we get either a red card or a club. So the probability of red or club. Okay, well, in probability the word or means add. Okay, so what we do is we look for the probability of a red one, red card, plus the probability of a club. Okay, and since these events are mutually exclusive, that's all we need to do with it. We don't need to make this any more complicated than that. Okay, so we're taking a card out of a deck. There are 52 cards in the deck, and half of them, 26 of them, are red. So the probability of getting a red card is 26 out of 52. Okay, now instead of that, let's imagine we were trying for a club. Well, again, if the 52 cards in the deck, 13 of them are clubs. Okay, we get 13 of them as clubs. Well, if we add those two together, they have a common denominator, and that's why it's good not to reduce them yet, because they already have a common denominator. We end up getting 39 out of 52. And if we divide that by 3, okay, if we divide that by by 13, divide by 13, and divide by 13, we get, oops, sorry, beg your pardon, we get 3/4. Okay, so the probability of getting a red card or a club is 3/4. Okay, let's go back to the rest of the question again. So in question B, what we're doing is we're trying to find the probability of getting a diamond or an ace. Okay, well, there are aces of clubs, there are aces of spades, there are aces of diamonds, and there are aces of hearts. So, this time around, so question B, probability of a diamond or an ace. Okay, well, the ace of diamonds is in both categories. It's both criteria. It's an ace and it's also a diamond. Okay, so that means because there is one card, and you only need one card, but if there were more, that would also work. But because there's at least one card that's in both camps, we say these events are overlapping. Okay, these events are overlapping. Now, when we look for the probability of getting a diamond or an ace, okay, well, remember, or means add. So we look for the probability of a diamond plus the probability of an ace. Well, we have to guard against counting the ace of diamonds twice. So what we do is we subtract the probability of getting a card that's in both camps. Okay? So, the probability of a diamond. There are, out of the 52 cards, there are 13 of them that are diamonds. Okay? 13 diamonds. Now look for aces. Out of the 52 cards, there are 4 that are aces. And then look for the probability of getting a card that is both an ace and a diamond. Well, there's only one card that is both an ace and a diamond, so 1 out of 52. So this gives us 13 and 4 is 17 minus 1 is 16 out of 52. 16 out of 52. And I think you can divide both of those at least by 4. And if we divide those by 4, we would end up with 4 over 13. So the probability when you take a card from a deck that it's either a diamond or an ace is 4 out of 13. Okay? Hopefully this makes sense. Can be a little bit tricky to think about the both, but it just comes from spending a little bit more time thinking the problem through and thinking of all the different possible outcomes. And remember, the numbers and the fractions are the numbers of outcomes that are possible. Okay? Thanks for watching.